proposals that were submitted to this workshop, for which I think we will have 12 in total. So this will be the first one. But before introducing the speaker and the proposal, I just wanted to tell you that after the presentation of the proposal that Kostas will give, we will have a discussion. So we'll have a 30-minute presentation, then we will have a 60-minute discussion on topics related to the proposal. And then at the end, we will have a few minutes to kind of discuss the working group charter that will be set up, its goals and milestones. Also, I will need a volunteer to be a note taker for our discussion. And the note taker, please send me a private message in the Zoom tool if you want to volunteer. And all notes will be in the HackMD, and you can find the link for the HackMD document in this main link for the workshop. So without further ado, let's go to the presentation for our first proposal, which is distributed auditing proofs of liabilities. This is a proposal by the Facebook Calibra group, and which is Kostas Chalkias, Kevin Louis, Payman Mohasal, and Valeria Nikolenko. Our presenter will be Kostas, who is a cryptographer and blockchain engineer at Facebook Calibra, focusing on privacy-preserving protocols and contributing to Libra's crypto API. Before joining Facebook, he was the lead cryptographer at R3 and the Corda blockchain, mainly dealing with SGX and confidential transaction filtering. Prior to that, Kostas was the CTO of 2 security and machine learning startups, where he built a platform for fair and secure national exams using time-lapse cryptography. His fields of expertise include identity-based encryption, time-lapse encryption, auditing protocols, secure enclaves, impersonation attacks, graphical passwords, and hash-based cryptography. Kostas also implemented and attacked a number of smart contracts in the past. He is an active contributor to various open source crypto libraries. So with this, I give the floor to Kostas. I think you can share your screen now.
Can you see my screen now?
Yes.
Okay. All right. Give me a moment. Can I? Cool. So yes, I'm Kostas, and together with my colleagues Kevin, Payman, and Lera, we're working on creating schemes for auditing proofs of liabilities. I will just give a very brief description of what is this presentation about. So we focus on a particular class of auditing cases. And I'm stating this because I want to clarify that we try to solve problems where the audited entity doesn't have any incentive to increase the liabilities or obligations. But there might be incentives to decrease it. So imagine there is a requirement to publish a number, and this number might be some liabilities you have to your clients if you are a bank. There might be the daily COVID-19 cases per city, per hospital, and there might be an incentive to keep this number small. It's not only the incentive, you might need a way to verify that all of your mechanisms from the below actually work up to the reported total number. We don't care if you want to increase the number, and we are mostly interested on providing some proofs that you cannot actually make this number smaller with some probability. So we have a number of applications. The most important are categorized into 3 major fields. One is finance, the fundraising thing, and the solvency. Fundraising is when you want to let's assume you're a charity, you want to do some fundraising, and you want to ensure that all of the donors can actually check that their money are included to what, for example, Greenpeace or other companies are advertising. And the same is for solvency. If everyone goes to to its bank and we all request withdraw, let's withdraw all of our money, if the bank will be able to provide the proof that you can do it, or if they are running a fractional reserve, you can do it up to this %. And there are applications even in e-voting. Imagine that we want to count dislikes, or we want to, instead of having the conventional e-voting election system, we're putting our preference vote, we're now putting negative votes. And imagine this is completely decentralized and people want to receive their votes in their local infrastructure, like you're voting for a party and the party holds the votes in itself. There is no government running the elections. And then they need to publish this number, and we want to ensure that you didn't actually remove some of the negative votes. And now, and obviously we have the official reports with the current case of the pandemic. It's the same thing. We want to ensure, for example, that hospitals are actually reporting the numbers accurately. And if there is something, for example, that was missed during the weekend, they can go back and check what happened in the process. So in theory, the problem statement is actually very similar to all of these applications. They share the logic of publishing a number, and we want to ensure that this number is accurate. And the recommended approach is we allow the users who are actually are involved into this number aggregation to privately verify their inclusion. It's either it's balance for solvency, either it's a vote for voting negative, disapproval voting, or it's a case, a virus outbreak case in the reported total. So that's the recommended approach. The purpose, I want to make it, let's say, I want to clarify this, is that we want to agree on a scheme. And I'm mostly afraid because of my past experience on moving sometimes slower on the, let's say, zero knowledge proof schemes that we can use. And obviously every month we have a newer scheme, which is faster, but we never took a decision on the previous ones. And this goes like forever. And we want to, at least for this particular case, for auditing, to agree on one or two schemes with different probably properties, like with a trusted ceremony or without one, post-quantum. It's up to this conference to agree on the, let's say, the parameters that we want to actually standardize. And the aim is to fix the industry inconsistency on the auditing tools, especially for the proofs of solvency. We have now blockchain wallets, and I personally have seen at least 5-6 different ways of proving solvency. And all of them are using a variation of the original algorithm, like the Maxwell one. Nobody's using zero knowledge proofs, I mean, at least in the banking sector. And we need a way to actually standardize these things. And I also had the discussion with many auditors like Deloitte and Antonio Senatore, who actually helped us a lot on providing feedback on this. And they need to re-implement everything because there is no standard. A company goes there and they have to implement everything from scratch. So it is clear that outdated privacy preserving techniques are still widely used. So we've seen it in many cases. And the pragmatic expectations, as I said before, it's 1 or 2 concrete schemes, have a reference proof of concept implementation and test vectors. And also because this particular problem combines a couple of features that require zero knowledge proofs, like range proofs or set membership and proof aggregation, it might be also a good example to be used for benchmarking of all of the upcoming zero knowledge proof schemes. And it's not a goal to actually have extra properties outside of the original concept, which might be, okay, you're using this for e-voting, but also in e-voting, we need extra properties to be satisfied, like defend against coercion or bribery and other stuff. So these are out of scope. Imagine it as being a primitive, and people will eventually use it along with other cryptographic primitives to build their system. And also, we're not going to talk about specific signature schemes or any other tools required for private proof downloading and tracing of who downloaded what, and this is also out of scope. So just to give you a view on what is proof of solvency, because the whole presentation will be based on this example, and after you understand this example, we'll go through the details of other applications. So in proof of solvency, we have to prove that the liabilities, so the money people have in a bank, are actually, this amount is smaller than the assets that the bank holds, like gold, bonds, other investments, and which actually prove that even if everyone tries to move their money, we're still solvent, we can pay you back. In a wallet, in the blockchain, this is nothing more than users on the left side. We have the wraps. We have a local database, which is our liabilities. So these are the balances users see. And on the other side, we have the assets. The assets is, if you are a Bitcoin wallet, it's actually the money that you have, the coins that you have in the blockchain. However, as we said, we only focus on the liabilities part, and we don't actually consider proof of assets, only the liabilities part. And the reason is this. The reason is because different blockchains have different ways of providing privacy and transactions. Like imagine you are a VASP. VASP is a wallet in your mind, and the VASP is connected to, it might be an exchange connected to Ethereum, Bitcoin, Libra, I don't know, whatever is the other blockchain. However, all of these blockchains on the right side might have different ways to prove assets. That's why we only focus on the liabilities part. So Moti also mentioned that the MPGOX case back in 2014, where about 850,000 Bitcoins were stolen. And at its peak price, this was 17 billion worth in dollars. And imagine if there was a way, even after this happened, or just before this happened, that MPGOX would prove, oh, I have your money, so I'm still solvent, or at least I'm 90% solvent. And this happened out of surprise because then they couldn't prove anything and they lost their money. So what are the options that we have for liabilities? One basic option is we publish everything. We expose everything to the public. So we go and say that Kostas has 10.34, Daniel has 14.16, and everyone is actually included into this report, which means that people, outsiders can actually see individual wallet balances. They can see wallet identities. They can see the wallet performance from month to month. Zero balance customers, total liabilities, everything is exposed. Obviously, we don't want this, and we needed something different. Second option is to use auditors. So even in the past, when Deloitte, Ernst & Young, PwC, and all of the other big organizations for auditing didn't touch blockchains at the very beginning. And for example, I personally work with Mike Hahn, who used to be an auditor, a single person auditor, where the company asked them to go there and run some MySQL queries to the database and say, oh, I proved that the size of the company's deposits and liabilities is actually correct. And it was back in 2014 again, where I was personally amazed by this statement that until we can implement full zero knowledge proofs, which can result to cryptographically provable audits, we have to trust the auditor. And now we have zero knowledge proofs. So it's probably time to actually do it. So even until now, the major way to provide solvency is creating Merkle trees, summation Merkle trees. So the conventional Merkle trees, as you can see here, where we are also adding values up to the root. So it's just the hash, as we know for Merkle trees, and also a second element, which is the balance. And as you can see, in this particular case, if we have a user being like a user in the leaf structure of this tree, so this user will check inclusion to the actual published information by checking a verification path of the Merkle tree. However, as you can see from the gray shaded boxes here, this user can learn things by the neighboring cells, by the neighboring nodes. So we have user B who can learn that there is another user who has 11, and there is another user on the right, actually two users on the right, that accumulatively they have 30. So even this one, as you can see, it exposes information. In 2018, actually, in the in an auditing happened by Deloitte, this algorithm was still in use, which is 2 years ago. And it's a good step. So it's better than the previous one where people were going and running MySQL queries. But however, there was some exposure to the auditors, like the auditor had full access on the leaves in this particular case. So although nobody else could see the balances, the auditor could be able to see the balances, while the objective was proof of solvency. It's not see what are the individual balances. And there was a leak actually, because you learn the total liabilities when you are doing proof of solvency on a regular basis. Imagine if you are doing it per month, you learn the performance of the wallet, which might be an internal information, and someone can go and, I don't know, do trading even before the official announcement of the company. And to the customers, obviously, as we said before, you learn something about other customers. Even if you cannot see that it's Alice next to you, you can see that there is someone with a balance of 11. And also by the tree size, you can predict with some probability, I mean, in a range, what is the number of customers. So you can know by the height of the tree if there was 2 in the power of 10 customers, or 2 in the power of 11, or 2 in the power of 40, 2 in the power of 42, 41. So there was an extra step that we could do is, okay, let's assume we want to hide this information and we don't want to get into the advanced technology of zero knowledge proofs. So a naive solution would be to split the balances. So split 17 into 5, 3, 3, 1, 3, and 2, print another balance differently. Imagine that you have a max, like 5 coins is the max. And what you do in the bottom of the screen is you get all of them, all of the split, all of the denominations, and you shuffle them. So you don't know if subsequent leaves correspond to the same user. And after you reshuffle them, you put them in a tree. So in this particular case, what happened is the tree is bigger now. Imagine because of the denominations, we have bigger trees. And we lost some information about our neighboring nodes. We know there is someone with 3, but this 3 doesn't correspond to the actual value. It's just a denomination of the a smaller subset of the balance of the user. So yes, we get something out of it. And what we get is we are exposing to the auditors still the total liabilities. We didn't hide the total number. And the denominations actually can reveal a few things. You can learn a few things about using the distribution. On the other side, the customers can still see sibling denominations. Maybe in some applications, even the fact that you know someone next to you has 1, balance of 1, might be something that you can use. So we don't want to make all of these, let's say, advanced system where you have to define, okay, what's the max denomination I can use? And if this max is enough, or I can go back to something different. And then in a few years from now, there is the dollar or whatever is used here is like there is a recession in the economy and it has bigger value. Now 1 has is nothing, or it has lower value, and 1 is very important. We shouldn't expose 1. So another option was to use SGX. We all know what enclaves are. It's actually something running inside a secure hardware. Assuming there are no side channel attacks, and SGX can actually replicate, simulate a zero knowledge proof inside the secure hardware. However, as you can see on the gray box at the bottom, it's more difficult to make stateful enclaves. We're still aware of side channel attacks that can happen to enclaves. We need to trust Intel for SGX. And also, we don't know how expensive it is to do decoupling attacks. Like you get the CPU, I don't know, you're using Glazer or Axids or something else, and you're trying to extract the private key from the enclave and simulate and actually build another system that simulates the enclave logic in software. So this usually costs millions. It happened before in other systems, but we don't know how expensive it is for SGX, but it might be possible. And here is what Moti said, zero knowledge proofs to the rescue. So One way to avoid including balances on all of these statements is to actually hide the number. And the easiest way, for example, is to use homomorphic encryption. So imagine we're having 4 users to make it simple. And these 4 users will have some balance and the user ID. And we want to hide the balance. As you can see, is cryptographic 1, cryptographic 2, C1, C2, C3, C4. And this is a commitment. This is a commitment to the value, cryptographic commitment to the value. So from this one, I will explain what's happening in practice. So imagine you have a wallet, you have your balance, or you have a user ID. Let's assume your user ID is your email. The company, who is actually the wallet, will give you an audit ID and a blinding factor if these are Pedersen commitments. And with this audit ID and the blinding factor, the audit ID can be used actually to produce a hash for the user. So the hash of the user is audit ID concatenated with the user ID, which means that all of the hashes, because we have the element of user ID, even if the company is malicious and uses the same audit ID per client, there will be different. The audit ID here is like, it's used as a salt to hide the user ID from externals. And so we have hashes which are unique, that's good. And eventually we have commitments over some value, and then we add these commitments up to the root. And obviously, because these are, in this particular case, these are Pedersen commitments, we need to accompany them with some range proofs to ensure that everything added up to the root doesn't overflow. So just to give you an insight on this, the original schemes, especially provision schemes proposed in 2015, had a flat version. So there wasn't a tree, but there was mentioning inside it that you can convert this to the tree version. But as you can see, the flat version has some other problems, and I will explain how do we solve them. The problem here is, I'll go back again. The problem here is you cannot hide the size of the tree, the size of the population. And if you try to hide it, going to this, you have to add fake users. So imagine, as we said before, you can always increase the amount of liabilities if you want, if you have an incentive, but you don't have an incentive now. It's liabilities. And by adding fake users, what you're doing is you're adding fake leaves into the tree. However, imagine that if we had only 100 clients or 1,000 clients, and we wanted to hide the size of this particular population into a power of 40 of 2, this would require 2 in the power of 39 plus something fake accounts, and would make the tree huge. It still works, but if you want to ensure that you start with a wallet with small number of users, eventually you have user acquisition, you go more and more, subsequent proof of solvency, if you didn't have fixed the maximum possible number in the future, one day, if your wallet became so popular, you have to jump to a bigger number, and people will realize, oh, you're having more users than you used to have before. So it's better to start from the very beginning with 2 in the power of 40, for example, or 32, or whatever makes sense, and stick to this for years. The other problem with provisions is at the time it was published, efficient zero knowledge proofs didn't actually exist. They just started to appear. And in their bulletproofs presentation, many of the authors actually were the same with provisions. They proposed, hey, maybe now we can use bulletproofs for all of these range proofs. And actually, because we have the aggregation property of different proofs, we can actually make all of the paths, all of the range proofs to be one, which scales linearly, but not even sublinearly to the number of leaves. And another thing, as you've seen before, I will go back again, is they've sent a different blinding factor and a different audit ID, which means that two pieces of information should be transmitted. And what we say is, you don't need this, use a KDF, and with the audit ID, produce the blinding factor as well. So in theory, you can save some information required to be submitted by the wallet. Going even further, another problem with this approach is the company can manipulate all of the audit IDs. So people who are likely to check their proofs are next to each other. And because you can fix the sequence of the tree. And this might create some inaccuracies on the part that parts of the tree might be completely nonce or completely wrong. And you would never be able to realize because nobody is there to check a path. Even if people check, nobody is there. So what we propose here is we can have a deterministic derivation of all of these audit IDs. And the way people can do it is actually by using a VRF. So imagine you are having user IDs, and also the server has public keys. What if you can produce the audit ID deterministically with some VRF and maybe a KDF on top of VRF just to ensure you have the size that you want? And in theory, you are having a seed now that every user can check. It wouldn't be different. I mean, for each particular audit sequence ID, by audit sequence ID, I mean the audit at day 1, day 2, day 3, day 4, you know what is your audit ID. I mean, the company cannot actually change it and put you somewhere else in the tree. And with this audit ID now, this is a seed, you can create blinding factors and you can create the seed for the hashes. So this would allow you, eventually, if we have a tree which has all of the nodes, let's say lexicographically ordered based on the hash, the company couldn't actually, the audited company couldn't actually cheat on where you are in this tree because it has been deterministically derived and all of the users are actually have the same thing. So you know if another user has a bigger hash than you, he will be next to you on the right. And also another interesting thing is until last year, for example, the audit key was provisioned on every single proof of solvency. What we can do now with the VRFs and KDFs, when you register to an app, you get an audit ID, or you can even provide your audit ID. Now mobile phones have enclaves, they have secure hardware. And eventually you are using the same audit ID for all of the subsequent audits. And this actually gives you the opportunity to, after registration, not requiring any audit information to get your blinding factor. You can produce it. You know what your blinding factor will be. So another thing, how do we solve the padding thing? Imagine previously we said, wow, I had 1,000 clients and I want to hide the population up to a size of 2 in the power of 40. So there is a trick here. You can use sparse trees. And in this particular case, we say that the black dots are real users and the gray dots are padding. And what we can do is, if after creating all of the VRFs, KDFs, and we know the index of them, what you can do is in between them, you can add some nodes that correspond to a whole subtree, which means that in this particular case, you don't need to implement to actually encode all of the remaining fake users to reach the number of 2 in the power of 40. You're only needing like double the size of the accounts that you have. And this actually was very helpful because now we can hide any size of population without introducing a huge, let's say, number of fake users. And going even further, this even allows random sampling from auditors. So we're trying to evaluate these things in practice, right? We're working in Calibra, which is a wallet for Libra blockchain. And we want to see, okay, we have the conventional auditing firms on one side. They're doing their audit. It's okay because this is also super helpful. But the problem with these particular cases is because they don't see balances. They don't really know when they come to our database if someone corrupted the logs or the databases. They couldn't have this information. So let's assume this DAPL scheme is actually a complementary tool to the auditors. The auditors in some particular cases, especially in dispute resolution processes, they might request sampling, and they specifically want to reveal some leaves. And what is happening is probably they roll the dice and they say, okay, give me the 7th leaf or 9th leaf and blah, blah. What we can do now is, because we know that fake users will have a specific construction, if Deloitte, for example, asks for the 11th leaf, we can give them a proof that, hey, the returned index is 8 because nothing exists at 11, and the closest to 11 is 8. And as you can see from the path, 9, the one on top of 10 and 11, and the other on the subtree on the right, are fake users, because we give you the information how these fake users are constructed. And so you can call number 8 and see if the balance is actually included. And eventually we will have a system like this. This is double, where we have users, and on the right side, we might not have other users, for example, and this is just a fake user on number 4 on the top right. I will not go into these details. You can go and check the white paper on this. But yeah, as you can see here, the only information required by the user is a user ID and a value. And then we run the VRFs, KDFs, and all of this to implement the tree. Another interesting property is you can have layers. Now that we have all of these things with Merkle roots, imagine in the COVID case, for example, hospitals report numbers, the hospital reports to a city, the city reports to a county, and so on. So in theory, you can have all of these leaves from the bottom, which are users, that they can see their inclusion in the hospital report, in the city report, in the county report. And if any of the above layers actually sees a problem, like a user says, oh, I'm not included for some reason, they can go back and check what happened in the process. Maybe a hospital had an issue with their system and they couldn't report accurately, and so on. So that's the idea of DAPL in general. We do have various features here. For example, we're hiding the total value. As you can see from here, the total value is still a commitment with some range proof. So even in proofs of solvency, you can compare this root at the top with something that you have on chain without never revealing the assets of users. In other cases, like the COVID case, you might want to reveal this anyway. But there might be other cases where countries wanted to compare their own numbers without ever disclosing their numbers. And so the idea is you're using the same scheme for different applications depending on the requirements.
By the way, what does DAPL stand for?
Sorry?
What does DAPL stand for?
Distributed Auditing Proofs of Liabilities. It's the acronym of the presentation.
Okay.
Sorry for this, yeah. So we found a way to hide the total value. We hide the account values and identities. We hide the size of population. Obviously, because it's a tree, imagine a difference between the original provision schemes and the tree-based scheme is because you are adding all of the leaves in a flat model in the provisions, you have to ensure that all of the individual balances together will not overflow. So when you add A plus B, this doesn't overflow. B plus the next, I mean, this aggregation plus the next doesn't overflow. This with the next doesn't overflow, which means that you reduce if you had 2 in the power of 40 leaves, for some reason, it's not for solvency, it was for payments in general. So you might have 2 in the power of 40 payments in the world. The range that you can agree on the flat model is smaller than what the group can offer. But with the tree, we know that addition in the worst case will happen to up to 256 leaves, paths, which means in the worst case, you just remove 8 bytes, like the log of 256, from the group size. So if you have a group of 256, 2 in the power of 256, then you can get ranges up to 2 in the power of 248 per value, which increases the range that you can include in the system. And there are also other features like deterministic tree, auditor sampling, reusable audit keys. and new applications outside solvency. And the extra requirements and recommendations is obviously this route to avoid any splitting attack, where you have two sources of truth. Should be, let me see, there is a message, I cannot read it. If there is a message, I cannot read messages while speaking, so please let me know. So the nice thing with this is, with blockchains now we have a source of truth. You can publish your root there, so nobody can say, oh, I had a different view of what is your root, and someone else says, for example, you might try to trick some people and give them a different root. We need to predefine where we're publishing the root from the very beginning. And there is another thing, which is you can use also private information retrieval to hide who downloaded proofs. Because imagine in subsequent audits, especially for solvency, if the wallet knows that some people are usually good checkers, I mean, they're good citizens and they check their balance, but some others are not, if I know who checked, I can omit them. So it's good not to have the information on who actually checked. And obviously we need signatures. Mutual contract, we need signatures because in dispute resolutions, the user will never be able to prove that, hey, this is what I received from the wallet as a proof, or this was my audit ID, or all of this stuff. So it's better to sign this stuff. Applications now. And that's the interesting thing. Everything before that was focusing on solvency. But then we realized, wow, solvency is just like 3% of what can happen. Imagine we can have the same logic, exactly the same, for syndicated loans. And if you don't know, the concept here is, imagine syndicated insurance on loans. Imagine there are insurance companies and they want to create an insurance contract for a country. And not only one of them would like to get the full responsibility of this, so they split the risk. But there is a collector, and the other companies that go into this consortium now, they don't want to reveal how much money they actually invested on this one, because you learn information about other banks, you learn information about Bank of America, about HSBC. You shouldn't do that. Only the collector might have this information, but nobody else. Taxable income. Imagine a world without IRS. So Amazon, for example, reports their annual earnings, and you can check if what you bought yesterday was included in the annual earnings. So you can actually check your inclusion in the report. Credit score. Imagine we didn't have Experian in all of these companies, and each individual carries the credit score in his or her own ledger. And banks can check if the loan that you bought, imagine that this credit score is only for negative things, like liabilities. A bank can actually go and see if the loan or the mortgage is included. However, there is no centralized authority like Experian or someone else who knows all of your credit score. You can advertise whatever you want, but you might be caught if you're cheating. Fundraising, as I said before, there might be cases where companies are, like charities, are revealing that they raised $1 million, and this might be $5 million, and maybe something was lost in the process, and people can check that all of the donations, at least their donation, is included. Voting, counting dislikes. Imagine we have Reddit, and we're counting dislikes on Reddit, and we know that, for example, Reddit cannot go back and say, oh, I didn't have 50 dislikes, and everyone can check if their dislike is included. And this might also be hotels and restaurants. Imagine TripAdvisor we have now, and other services that they actually giving information about negative and positive reviews. If there was something for negative reviews, each restaurant or hotel will hold its own liabilities. Nobody else knows the liabilities, but you can check if your negative vote is included on what they report every month. But you don't need TripAdvisor anymore or other companies. You still need them for other auditing purposes, but you have the power of decentralized checking as well.
2 minutes.
2 minutes?
Yeah.
Yeah, thank you. And as I said before, the same is for disapproval voting, as I explained at the very beginning. And imagine a two-party decentralized election where we have, for example, two competing parties, and you are sending your votes, your positive votes to the other party, and let's say you want to vote for party A, but you send your vote to party B, and you send your vote for party B to party A. So for them, it's liabilities. So they need to report something without having a government running the elections. And still, users who voted negatively for you, they can go and check afterwards. And reporting, especially for virus outbreak cases, unemployment rates, work accidents. Imagine lottery jackpots. Do you believe it's 3 millions, or it might be 5 millions in the lottery jackpot, and people cannot check if their ticket was actually included in the amount published. And tracking system. Imagine if in the chess, for example, you were only counting defeats. So you will publish how many defeats you have, but people who won over you, they can go and check if they're included there. So one research idea actually is this. As I said before, you can use it for virus outbreak reporting. It's exactly the same algorithm. Very quickly, what we could do is, it's a research idea, right? So we're not collecting any data or something. We're just trying to see if zero knowledge proofs can actually be found useful. You scan your test, then the hospital eventually reports a number, and you can verify if you're included in this number. And if you're not included, you say to the hospital, hey, I'm not included. Can you see if something happened to the system? And the hospital will probably include this in the next day report. And yeah, that's all for the presentation. And many thanks to everyone who actually helped on this. From Deloitte guys, Daniel here, people at Calibra and Facebook, and definitely Provision, Zero Ledge, and Bullet Profs. Definitely, actually, they helped a lot on the ZK Ledger as well on this particular document. Thanks a lot.
Thanks, Daniel. Thanks, Kostas, sorry.
It's okay. Daniel also helped on this.
Yeah, I got carried away by your presentation. So I think now we enter the discussion phase. So since it's very hard to see all the people that raise their hand, let's try in the beginning that people who want to talk just try to talk.
And I will stop sharing because I cannot see anything if I'm sharing.
Yeah, I think that's okay if you stop.
Okay, sorry. Thank you.
And also, so in the HackMD, we have a couple of topics that we could start discussing, but also if people want to propose topics that we should discuss that are of interest, we can do that as well. But the first topic that we wanted to kind of start with, which is also the most kind of relevant to the nowadays situation, is this application that also Kostas pointed out in settings where we have these virus outbreaks. How could such systems be helpful? And do people in general think that this would solve issues that we are currently facing, such as government underreporting, misinformation, maybe contact tracing, or any other ideas that people have? So I think this is the first proposal for a topic that we can discuss, and we'll try to limit our discussions to maybe 10-15 minutes per topic. I don't know, are we still supposed to finish in half an hour or less than half an hour? Daniel, do you know how is our schedule moving?
No. We start now another 60 minutes as we planned. So I mean, if anybody has to drop, unfortunately, we had this glitch at the beginning, but let's follow through with the 60 minutes discussion.
Okay, great. So maybe
I lost track on if there were any questions in chat. I lost track while presenting, right? So if there is something, please let me know now.
Yes, maybe if there are questions for the presentation, we can start with them and then move to the topics. Okay. So please, if you have questions, you can ask them now.
I think there is a question there on the chat.
Okay, so I see this question. Is there a deterministic number of times verification has to be done by verifiers to ensure that none of the users are missed out?
Okay, so that's a good question. We have a proof, by the way, in the paper and listing the probability, actually the number of people that should check to increase the probability of correctness. It's a probabilistic model, right? So we cannot always expect that everyone will check, but because you don't know who will check, you're disincentivized to cheat. So to tell you the truth, from the experiments that we're doing, 15 to 20% of coverage is usually enough because you're covering too much space on the tree. However, in particular cases, we know there will be patterns, like people who have more money in their wallets, they're likely to check. So if you have 10 million in your bank, you have an incentive to go and check. If you have $1, you don't have an incentive. However, this $1, I mean, the small values, if they don't check, they're not doing a huge harm on the system because proportionally, this value is very small to the total, right? So we expect that at least in the solvency stuff, people with high balances will check. And if this is not happening, we have to automate the way. I would probably, I would personally wanted to hear ideas on how we can enforce more people to check, like an automated tool. Is there a way that whenever you open your app, it automatically checks on the background, or we have the generic scheme, like we standardize DAPL somehow, and all of the applications that are using DAPL, they have some open source implementations, and automatically every day you're opening your phone, you're checking your proof of liabilities in Calibra, your proof of liabilities in BitMEX, your proof of liabilities in your COVID cases, proof of liabilities in different things. So everything is happening automatically. That would be probably the ideal scheme. But even if this is not happening, we need at least a minimum amount of users. I don't know the real number for sure, but the bigger it is, the more disincentivize the companies or the reporting entities to hide numbers, especially if you don't know who is going to check. Good question.
So maybe if anyone has kind of a response to the question in the answer, of course.
Maybe Abilas, who asked, are you satisfied with the answer?
Yeah, thanks. I think it's pretty good to understand the answer. I think there is scope for improvement there as well. And I know that it's a distributed model, and then we have to ensure that there are no gaps involved. For example, COVID-19, let us say a government says that these are the number of patients who are affected. What is a way to confirm that nobody is missed out who is actually COVID-19 infected? That's a real problem we are facing now. So that can be a very interesting question. And I see that this covers a good amount of privacy, but at the same time, there are some areas where this can improve as well.
That's true. Yeah, that's why we're here, actually. I'm not saying we have the full answer on everything, right? So this particular one for COVID is very new. We even submitted the paper even before this happens. So there might be good ideas on how to improve here. I completely agree.
Yeah, thank you so much.
Thank you.
Have you thought about actually giving incentives for people to check rather than forcing them?
Good question. So the short answer is it crossed our mind that we can give incentives, but I don't know how it can be applied in a global scale. Maybe if you're a good citizen, you get something on your volunteering tokens. I don't know. Maybe we can find ways to give incentives. Well, imagine these people are patients, right? They're infected people, or some of their people actually passed away. So I don't know what is an incentive here. It's very strange. You want to protect yourself anyway, so you have an incentive to do it. You want to protect your family from this or your relatives. But you're right, maybe we can give other incentives as well. I'm open to any. Actually, this will be a collaborative effort, right? It might be even difficult for us to run it on ourselves. So we need all of these ideas to do it.
Can I shout a question?
Yeah.
I'm not quite sure if I understood the attacker model at all. So my assumption right now is your standpoint is the prover. So, for instance, the exchange is fraudulent, is malicious, basically. And then we have the auditor, which is honest but curious. And then we have the ordinary users who holds funds, who's basically honest. He's the second verifier, so to speak. One verifier is the auditor. The other verifier is the end user. And then we heard about something like incentivation, which is a game theoretic model that comes into the place, but only for the end user who's completely honest. And we assume there is no collusion whatsoever between any party and no subtraction of all those parties. Is this correct?
That's true. That's true. So in the ideal scenario, you don't even need the auditor, right? So, but what we realized is you cannot run anything only with probabilistic models. So you still need the auditor style of auditing.
You get muted.
Yes, sorry, Deloitte, Ernst & Young, and all of these companies to do it. But what they cannot check is if the actual reported numbers are real. So that's why you're adding this extra level. So I see them as complementary. You're right. There might be a collusion in theory. It happened in the past, actually, 10 years, 15 years ago. There was a fifth auditor, big fifth auditor, but now it doesn't exist because of such a fraud. Yes, if the auditor colludes, at least now the users can check. It's like a second step of, in the worst case of checking. None of them on its own is sufficient, but both of them offer something better than nothing. That's the idea. But you're right. It's honest but curious, and users should be honest, because if they're not honest, it's a game theoretic problem, and they might lose their money.
We have some questions in the chat. Would the people who wrote the questions ask them also, or should I read them?
So I asked the question about identity, how you handle that, because I think in the example you use, you had a corporation or an entity with multiple parties. In the case of COVID reporting, you may want to change that identity over time. Have you thought about that as a scheme?
Very good.
I think I lost you.
I think, yeah.
Kostas is...
Okay.
Is he not in the call anymore, or is he?
I don't know. He seems to be, that his picture appears, but he's frozen.
No, I promise I didn't try and break the system.
He's off the grid now.
Yeah, he evaporated like a zero knowledge proof.
The question was too difficult.
Maybe he's changing identity.
He's changing his identity now.
Are there any of the authors in the call? Maybe they can answer the question.
Let's see whether of the authors. I don't see. Oh, is Kevin here on the call? Okay, somebody said that Kevin and Lara are on the call. So maybe if they want to.
I think I'm going to remove Kostas and tell him to join again.
Sure.
Can anybody hear me?
Yes.
Oh, Kevin, do you want to answer the question meanwhile?
Sure. I can try to fill in while Kostas figures out his. Yeah. So I think for well, Kostas can definitely speak more to the details of the COVID example, but in general, this proposal doesn't really handle the identity scenario. We're kind of assuming that that problem has been resolved, and we're just supposing like we've already established unique identities for everybody. How do we do the distributed audit for the liabilities? Does that answer your question?
Yeah, I think it answers the question. I think it's just a case that I saw some of the contact tracing systems were actually changing the identity on a 24-hour basis, for example. And from a PII perspective, you have to be very aware that you want to be able to link it at certain points, but you also want to mix it to make it difficult for an adversary to see it. So I think that's an interesting topic, because we have this binary thing that on the one hand, yes, I want privacy, but on the other hand, I want to be able to prove that I took the test.
Right, exactly.
So thank you.
Thanks. I guess maybe if we have different opinions or different viewpoints on this, especially have people really thought about combining the ideas of this proposal with the contact tracing mechanisms? Because it seems that in those proposals, one goal is for people who sometimes to keep these identities, these pseudo-random identities, not linkable in some settings. So I guess a question is, have any of the authors thought about integrating the two concepts, or is there anything that's more subtle, or are there somehow conflicting goals in the two type of systems?
So I guess in terms of the mixing identities for contact tracing, that would be specific to the potential like virus outbreak application, but maybe wouldn't apply so much to, for example, like the bank logging scenario or what we're looking at with Bank Libra. Is that right? So if that's the case, I guess in general, like, so I agree that could be something useful to investigate for a potential proposal for COVID, but may not apply as generally.
Yeah, also, just that to bits to that, so different audits can have different audit IDs, and this will also help randomize identities, so you will not necessarily be able to correlate the trees between different audits. But we haven't explored this topic deeply, so this will require more thoughts.
Okay, thank you. And I'm using a different identity actually, so I'm using my wife's computer, so it's Stephen Holmes, but I'm showing up as Leanne Bettencourt. So just to show that there is really, multiple identities in use today.
Okay, I think we have Kostas back.
Yes, I'm back. Thank you so much, Kevin and Lera, for jumping in on this. I didn't hear what did you say, but I believe you. So yes, the idea, by the way, for COVID was that the user can actually give whatever they want, even a pseudonym. Obviously, they can cheat. They can just give a fake one that they go to the next hospital and they give a different one. But if people are incentivized not to do so, in theory, you don't need to reveal your real data. You can even give a nonce. The only thing that should happen is that this nonce is unique among everyone else. Because if you reuse it, then the company can actually, or who is reporting, can actually say, give one proof for everyone, and nobody knows that it's only me. It might be for me, and for you, and for Lera, and for Kevin. So the only requirement is that it's unique. However, the cross-checking is not something we explored. That's true. If you're a malicious user and you give the same user ID everywhere, or you go to 10 different hospitals and say, I'm positive, I'm positive, I'm positive, then obviously this is not captured by the system.
Thanks, Kostas.
Thank you.
So I think there is another question from Eric McCarthy. Oh, sorry, I missed one of the questions. Maybe Jamie Lockyer, if you want to ask the question that you wrote in the chat.
Hi. Yeah, so my question asks, it sounds like a distributed systems question, but it's really motivated by the idea that in big capitalism, the biggest entities can just keep circulating money round and round to hide how many assets they really have control of. And my question was basically, in a full working system where people start transactions, shake hands, you know, they've kind of got off-chain transactions or side transactions and take a while to complete, and then they eventually settle. That's a big distributed systems problem with time. Are these auditing techniques able to effectively take a consistent snapshot of all of the state of the system, at least adequate to make its auditing proofs? Or can people cheat by engaging in lots of transactions in a collaborative way that circulate money round and round and hide it?
Very, very good question. One of my first slides was why we don't deal with proof of assets. Because we have all of these payment channels, and imagine you have all of these locking scenarios, as you said before, and the asynchronicity there and a lot of stuff. So the only thing we can do for now, and what we try to actually fix here, is at least draw a line on the liabilities. So we say the liabilities is up to 12 o'clock in midnight. This is the snapshot, and that's why we need signatures for the transaction processing. So we had an order before 12 o'clock, and this is what happened on the liability side. So how you solve the asset side, you're right, it's an open problem. And actually there is no good solution. I had many discussions even with Ian Myers and other people on how is it possible to solve the problem with payment channels. Payment channels, you have no knowledge what's happening inside it, right? And this is a problem on the assets part, but it was out of scope for this particular work. So we just wanted to draw a line on the liabilities. And for the assets is different. We don't have a good solution here. Maybe if anyone has something to offer on this one and creating a proof of solvency now, not only proof of liabilities, that would be great. But there is no good solution for this.
I think we thought about this a little bit at Electric Coin Company in the context of voting protocols, actually, because obviously, if you're doing stake-based voting, then you need to make sure that that you are basing that on a snapshot of the stake. You don't want someone to be able to transfer a coin and then vote again. So there is a way of doing that. Basically, it depends a lot on how the payment protocol works. But in Zcash, for example, you would pick a given block, and then let's see if I remember this correctly, I can't actually remember how it worked. There are some
the idea was to solve, sorry to interrupt you. The idea was to solve the full proof of solvency protocol, like proofs of liabilities from one side, and then you had the way to prove assets at a particular time instant. That was your... Okay, cool.
So I'm talking about how to prove the assets.
The assets part, okay, cool.
Yeah. Sorry, I can't remember it well enough to describe it now.
Okay.
But it is possible.
Thank you for that. I hadn't appreciated it can be sort of boiled down to the difference between assets and liabilities. I guess when I'm thinking of a large kind of financial system constructed out of these primitives, I'm also thinking of the way that people construct derivatives and circulate, fake money to a much larger value than the non-fake money in some sense.
Yeah, so actually I remembered a little bit more about it. You can basically do a ZKProof that you held a particular coin at a given point in time. And the specifics of how to do that depend on the protocol, but that's the basic.
But directly, quick question, because we try to explore this as well, how do you handle payment channels? where people can lie there, right? They can collude.
Yes.
So
yeah, we were only considering on-chain. I think maybe you just rely on scalability, on-chain scalability protocols, and don't use payment channels, and then that kind of solves the problem.
Okay, great. I also wanted to share, so Eric McCarthy actually didn't have a question, but he had a proposed answer to what I asked about incentives. Maybe if Eric wants to share it, or otherwise I will read it out. But I found it interesting. I guess I'll read it out then.
I can read it. So the idea was that people who test positive and then survive might get a free movement passport. So if you don't register, you wouldn't get that, and you could register the hash of the user, and so that you wouldn't really be able to tie them directly without their permission.
It's not bad.
Yeah, I think this could be pretty compelling incentive if we have restrictions on where we can, or maybe you're not required to be in 14 days quarantine if you're living in New York, like my case. So that could be a good incentive. Are there any other comments or questions with respect to this application to the current situation? Or if not, we can move to a different topic.
I think there was one question on the chat that hasn't been answered yet, which is there a way of linking a physical asset like cash to the number that's reported? Maybe that's similar to the question about concurrent transactions, but it seems to be a separable question.
Yeah, just to clarify that for the proof of assets part, we didn't focus a lot on this because of all of these complications. Definitely for the proof of solvency, as I said, you need the proof of liability somehow, right? You need the number there. But for the proof of asset, it might be different per chain. I know Daria now mentioned about what is happening on Zcash, but maybe other systems require different ways of doing it. And in some particular cases, it might be completely impossible to do it in a private preserving way. I don't know. Yes, you did this because you already have the layer of privacy there, but what's happening?
Well, we haven't actually done it. It was just an idea.
Okay, okay.
Any other comments here?
So one thing that comes to my mind is that the proof of assets issue, it seems like you do have a sort of flip side of that issue on the proof of liabilities side. In that if someone comes along and says, hang on, I have a liability against you which you didn't track in your proof. So if someone challenges your proof, then you have essentially the same situation as the proof of asset again. That you can't really verify that within this closed system. So I think there's some mirroring of the problems.
So that's a good question, very good question. The only thing that we found, because there was not an obvious solution on how do you react on dispute resolution things, the only obvious solution is you need mutual contracts on every transaction. Now it's not happening. Now if I have a wallet and I do a transaction, I should sign it. The company should sign the order, and eventually you should have an extra signature that the transaction was processed. That's the only cryptographic evidence you can have to draw the line. Otherwise, you're right. There is no other way to prove it. That's the same thing for hospitals. When you go to the hospital should give you a statement that you are tested positive, that you should scan it or somehow copy it, and there is a digital signature by the hospital. It happened. So when I come back, you cannot tell me that it didn't happen. This might work for liabilities. The problem with the other parts, with the assets, I think it's more complex because we have asynchronous payments, especially payment channels. I have never seen any paper dealing with payment channels and proof of assets. It's very difficult because of collusion. You can always say all of the money in the payment channel is mine, and because I somehow colluded with you. And if the proof of solvency is not happening at the same time against me and against you, then in the next second, I can send you the money back. Or this never happened, because in payment channels, there is a very special trick where you can send me the money now, but we already sign a transaction for the next transferring the money back to you, but we don't reveal this to the auditor. However, it's a risk-free for you to help me because you already have your money back if you want. So it's a collusion. It's very interesting that in payment channels, you can have a risk-free collusion. So the one who gives you money, they don't pose a risk. They can get their money back, even if they help you. So that's the main problem there. While in liabilities, we can live with signatures, at least up to a level of, let's say, trust on this particular system, like milliseconds and how a mutual contract is signed.
But in the case of a payment channel, the auditor can still see how much money is locked up in the channel, right?
Yes, but it might not be yours. You might have zero now there.
Right.
That's the problem. And imagine that there might be payment channels between big wallets, and this payment channel might be billions. Like, I don't know, BitMEX against Coinbase, they might have their own payment channel, and this is many, many millions there.
So does it need, I mean, the main motivation of payment channels is performance, right? So you only need the amount locked up to be so large in order to get most of the performance benefit.
Yes, true. But it's an open problem for crypto in general. Yeah. If we can find a way for proof of assets in payment channels, defending against collusion, that's an open problem, different from what we're trying to solve here in the proof of liabilities, but it's an open problem. It's a publication. If you have a solution, it's a publication.
I think we spent more than the allotted 15 minutes for this topic. So I think we should move on to some of the next topics. And I would actually want to skip the discussion on applications or leave it for the end if we have more questions. I want to bring us back to something that maybe is more directly connected to the goal of this standardization effort. And I want to ask the questions like, what exactly should we standardize? Should we standardize one or two specific constructions for this specific problem? Or should we be looking at some requirements, a set of requirements that would make any solution that satisfies them be acceptable? Where do people think we should be focusing on? And I assume the authors of the proposals are on the side of standardizing the specific constructions. So is that right? Like, what do people think? Like, how should we standardization here?
I will give our view. So when we started doing this experiment and figuring out what's happening in the industry, we realized so many inconsistencies. So for us, it would be ideal if we had a consistent system. I'm not against adding new features or fixing any processes of this protocol, but because I'm personally involved in zero knowledge proofs from the very beginning, right, from the very first conference, and I see that this problem exists now for proof of solvency, for example, for 6-7 years now, and we don't have a solution. So that's why we said, let's at least agree on something that is tolerable, and then we can work on extra features afterwards. Because before that, it might take 2 or 3 years until we have a solution. And till then, there might be many wallets who go bankrupt because we had a solution that could fix some of the problems, not all of them, but now we have nothing.
I guess the question was not about adding features, but rather kind of crystallizing the requirements that we have. So for example, in your presentation, you was presenting one solution and outlining what could be an issue, what could be another issue, like going to the next one. So should we come up with the set of requirements for solving this specific problem that you care about? And might be other approaches apart from the concrete constructions that you proposed, and yeah,
we are open. Thank you so much for this. We are open on discussion on this. So what we would like to have is we should start on something that eventually will be standardized and used. So for me, we already have 15 applications there. People might think of many more. I'm sure there will be even double the size. Can we find a scheme like to be used as a primitive whenever you want to do decentralized auditing? This probabilistic model, at least, because it's probabilistic. You can use this. I mean, like you're using RSA for signing, for distributed auditing, use this. This is one of the options you have. And then if you need more properties, we don't care, go find them. But I feel that we need at least the minimum of requirements that probably fit to most of the applications, at least the ones enlisted, and have a concrete scheme for how do you do distributed auditing. At least this was our plan originally. But we are open on any feedback on this. Might be not enough, or you might have better ideas. That's the purpose of this workshop, right?
Yeah, I wanted to add that maybe I think it's important to have a bit of both, Mariana, of what you're saying. Have either the requirements or the specific scheme. I think it's important to have the requirements very well defined, because then you know exactly where you're working, in what scope in some sense. But having a scheme that actually leads to somewhat of a reference implementation or something is going to be useful to make sure that people are not going to mess up when using the protocol, right? I would even say to have the protocol like standardized from the requirements, and then from the functionality, and sort of abstract the functionality away from the primitives, as Kostas was saying, right? And then fix the primitives as part of a specific example of using this protocol, right?
Daniel, quick question. When you say fix the primitives, so in my mind, I had something that we say we're using Plonk or bulletproofs, and here is how it works. Because the main part that is not purely defined here is what zero knowledge proof scheme we're going to use for the range proofs. So I mean, how are we going to agree on this if we don't have a zero knowledge proof scheme which is already standardized? How are we going to combine these things? That's my common problem on.
Yeah, I mean, okay, so go further.
I mean, you can specify what the requirements are, the security requirements on the scheme. And hopefully there are multiple schemes that could satisfy those requirements. For example, you might want to say that you need a scheme without trusted setup. It needs to be able to express this particular high-level statement, and so on.
So Daria, if it was, I mean, if you were in my shoes, for example, what would you suggest? Like, we want these schemes to be used. It's even outside solvency. Solvency is one of 20 different things, and we want people to use it. If we leave it completely open, what scheme you are going to use, people are not going to use it, because you come into the same problem of now nothing is standardized, and they don't know, is it bulletproofs, is it Plonk, is it Halo, is it something else? My question is it possible through this process to have a recommendation, proof of concept implementation for this particular scheme? Like, as you said, let's pick one with non-trusted setup, one with something different, and another with another property, like recursive proofs for the layered structures. I don't know, something.
I guess my question
please.
how would we pick
there's a
one?
question that comes up a lot in our process.
Sorry, I couldn't hear two people speak.
Sorry, go ahead, Eran.
I think the first order of business is exactly what Dara said, which is to have a crisp discussion of the required properties of the scheme in each scenario, including the security properties as well as the performance properties that are pertinent.
Yeah, this is definitely the first step. I completely agree. This is the first step. I agree.
I mean, and my point is that you were saying pick one. Like, I mean, there are many systems that achieve very comparable properties, and us picking one seems to be like a burden in us deciding and comparing between these different solutions. And I'm not sure whether we should be doing this as a standardization, or I guess that's a very tough question. What will all the authors of all the different solutions that supposedly achieve the same thing?
I mean, we want to produce an implementable standard, and that includes making sure that a given choice of proving system and protocol will fit together, and there's one way of implementing it. I don't know whether our progress on standardizing the interfaces of proving systems is good enough yet to do that. And what do people think?
Yeah, I wanted to say just in this respect that, and answering Kostas' question as well too, that one standard sort of leads to another standard as well, right? I mean, you want to create a standard of a given protocol. Well, what are the things that are there needed in order to actually standardize kind of the end-to-end? I think like the IETF is now doing the privacy pass scheme that uses the VOPRF scheme that is also being standardized, that uses the hash-to-curve scheme that is also being standardized, right? So it's this like recursion of things that need to be standardized. And as Dara said, I think there is in this workshop going to be like a couple of discussions on interfaces and another discussion on Plonk as well. So it's a matter of also seeing how to combine these things, right? These standards. So
I mean, a proof of concept implementation is going to have to make some design decisions about how those schemes fit together. And you can either just look at what that proof of concept does and standardize it, or you probably don't want to do that without looking very carefully at whether it made the right decisions, because it was just designed as a proof of concept.
If I may, I was cut off earlier. So I think that indeed the next step beyond clarity about the requirements and trade-offs is concrete choices. But I would pose these as software suggestions. So a reference design accompanied by a reference implementation, but making it as easy as possible to replace those underlying primitives and understanding what the ramifications would be. As for technical interoperability at the level of APIs and interfaces, so that is the topic of other proposals on the table, like ZK interface. And to the extent you can use these as levels of abstraction that would ease plug and play interoperability, that would be great.
Is there a plan that eventually at the end of this all of this event, for example, our proposal is somehow dependent on the ZK interface proposal, but before we hear about this, we cannot do anything, right? We don't have the solution of abstracting the interface here. Is there any plan after all of this 5-week thing to combine some of them together because they're linked?
I mean, there is no such plan formally, but I think ad hoc, a lot of different meetings can come up, right? That's why we're really setting up the working groups in order to have these discussions as are needed in some sense.
My question is, can we start, so during these days, we're going to form groups, can we start writing ideas on this proposal before the ZK interface actually gets presented? Or we should wait?
That depends on finding the right people who know how to do that.
Sure.
The real answer is that we're playing it by ear, and we are looking at the needs to find the processes that would solve them. In this case, I think we've just identified one question, which is what are the right levels of abstraction for plug and play interoperability of ZK backends? And is ZK interface suitable, or do you need something that is more specialized for range proofs and the techniques that you need here? That's something that I think would be a great topic for discussion in this proposals working group, as well as interaction with the other related working groups.
Okay, makes sense.
I guess a question for everyone is if you will be the user of this standard and you are thinking of the specific applications or wherever you'll be using it, what do you want to see in it? What would be the most useful from your perspective if people have opinions or suggestions here?
Are you referring to me personally or generally?
No, this is a question generally for people. Whoever here on in the discussions is this something they will be using? What as a standard?
Yeah, I would say specifically Kostas not to answer.
I guess, yeah.
Yeah, that's why I asked. Yeah, thank you.
Okay, I guess people need some time to chew on this.
Yeah. So first of all, I think half of the people that were here at the beginning left the meeting just because maybe they had other things to do as well. But maybe let's put that as a kind of a pin question on the notes that could be shared with the working group and see how that evolves, what kind of answers we get there. I think maybe I'm going to go ahead, Mariana, but I'm going to go share for now the working group link so that people can join that to if they want to keep updated on the discussions.
I have to leave, so I'm going to stop taking notes now. Bye, everyone. This was a really good discussion.
Thanks,
so
Sarah.
Should we, Daniel, then just say a few words about the working group and how this would be structured? I think we have like 13 minutes if we're precise, but maybe we...
Okay. Yeah, sure. I think that makes sense. Unless there's any other important questions or topics that people feel they really want to discuss. I mean, I don't want to take that from them either.
Yeah,
but
sure. If somebody has something that would like to discuss right now.
Yeah, I do have a question actually. Can you hear me?
Yes.
Yeah.
Okay, great. Yeah, it's the question for so I don't know if it's still online, but I'm wondering, I mean, I'm not very familiar with the construct you just detailed, but I'm wondering what kind of KDF you're using, like, and so on, because I kind of agree with what Daniel said before. Like in general, to have like a scheme being standardized, you start by standardizing the Legos you're using in your construct, and you kind of use the standard to standardize something bigger. And so I'm wondering if you miss one of these Lego being standardized. So do you miss a standard on, you know, the KDF or the VRF or something like that, or even like the data structure? You mentioned like a Merkle tree, which is quite a standard construct, but are you missing something else in your construction? Because I think it may be interesting to kind of look at the landscape of these constructions and kind of like factor all the denominators together to try and build this basis. And then we plug and play other standards like ZK interfaces and so on, and we can build something bigger.
Very valid point. So because we didn't know exactly how this will go, obviously we said KDF and VRF. We have something in mind, and we even have something for the range proofs. But you're right, we have to actually document well what is this Lego element is for all of the cryptographic primitives included on this one. And this, yes, this has to do with KDFs, VRFs, even Merkle trees, because there are some slight different implementation of Merkle trees. And this one in particular is using a sparse Merkle tree. It's slightly different anyway. And the range proof. So it's good. Yeah, you're right. It's a very good point, Daniel, to take this comment into account and have a list of all of the cryptographic primitives used in DAPL and take decisions individually. And obviously, as a community zero knowledge proof, we are mostly interested on the range proof construction. But the rest are also equally important. If we have a proof of concept, we need to define, hey, we're using HKDF, or we're using SAKE, or we're using something different for all of the other parts. Yeah, very, very good point.
I will add to this though that it is not necessary to start from the bottom up all the time. You can start somehow like standardizing the protocol. Of course, and again, abstracting the protocol from the primitives in a way that you can sort of plug and play standardized primitives, right? And some of these primitives may already be standardized, others may not. All others may just be standard by the way that they're being used, right? So and then going kind of one by one, as you're all saying. So to do that, I think this is important. So yeah.
I mean, I'm not necessarily suggesting this is the only way, but it's just a matter of like splitting a kind of complex problem into smaller, simpler problem, in the sense that we can reuse existing standards and kind of like have a bigger community in some way, because there's less disagreement and we can use stuff which have already been reached consensus upon. I mean, in my opinion, but again, this is only my opinion, right? But the same applies for like the proof systems per se. Like, do we really want to have Plonk or Gross16 or another snark as a standard? Well, I'm not quite convinced about that. Maybe we need to standardize arithmetization. Maybe we need to standardize like all these interfaces, and we can just let like the backend do what they want to do, right? So we can have multiple proof systems and like standard arithmetization, standard way to write stuff on files, and so on and so forth. So, but again, like we can discuss about that. Thank you very much, Kostas and Daniel.
Okay, so maybe we should go to the working group kind of outline, since we have only a couple of minutes.
Go for it.
So the goal of the working group that we will set here will be to continue the discussions that we started in this 1 hour session. We also would like to have the authors of the proposals as the leaders of this working group, since it's their best interest to come up with a standard based on this proposal. This should be open for comments and also changes that people want to see in this proposal, and kind of extending the discussion on what pieces or parts should go into the standard. And I think this question, what will be most useful for you, I would encourage everyone to think about it and kind of contribute in this working group in order to come up with something that will be most useful for the majority of the people who plan to use this standard. And how this working group will be structured, maybe Daniel can tell us a bit more about the technical part.
Yeah, absolutely. So I guess I will repeat this throughout the workshop, but well, as I can see already, a couple of people have joined. So the ZKProof effort uses the community forum, which is based on Discord, as a way to communicate about different topics with the community. And it has this nice feature that you can create some groups, and these groups can be public, anybody can join them and leave. The group can be messaged privately between the group members, or they can create posts that are public, like topics that are public, and just sort of tag or mention the group itself, right? So it's pretty convenient to kind of go between different topics and have lengthy discussions. It's very nice because it allows for LaTeX writing. The point is to kind of continue all these discussions. So we're going to post the notes again on this working group, and it's important for us to continue these discussions and set an initial charter, right? So the working group should have sort of like an initial charter where we outline what are the specific goals and the scope of these standard. So we've started discussing this, and I think it's going in the right direction. I actually have a short proposal about that in a second. But we also want to maybe set up some milestones ahead of the for the working group. One of them can include discussing with the interface or interoperability working group, for example. And I guess in a few weeks we would want to see a newer version of the paper that incorporates some of the comments that were given here or discussed here. And from there we see what the community in the working group would like to see. When there is consensus in the working group, right, we would like to push this to the steering committee for them to review it based on the criteria that they've defined, right? This is now actually work in progress. So I don't know, this work can take a few months maybe to go through, right? With respect to the charter, in terms of the goals or the scope, I think I'm seeing kind of more and more, based on also what Antoine was saying, that it makes sense to start by sort of outlining the privacy requirements right? So I would say the following. I would say first to like, as a way to make the standard easy to read and easy to understand, to fix an application and describe that application kind of end to end, right, as a flow. And then outline what would be the privacy requirements and define them properly, right, for this application. And then actually go into the protocol and say what are the specifics that need to be taken into account for a standard. Abstracting the protocol from the primitives, as we said, right? And then leave the primitives sort of out of the picture for the first version, at least, I would say. What do others think?
I personally agree. Give me, I just need to give me some information on how we're going to share the LaTeX, the document itself, so people can actually write together and contribute together. We're using GitHub, I guess, right? So we need some link in GitHub to start working on this.
Yeah. So we'll share everything on the working group. We'll set up the GitHub repository and make sure everybody can contribute as well.
Okay. Are there any other comments? So if there are no other comments, maybe we are also running out of time. We can wrap up this discussion. Thanks everyone for your participation. And we hope to see many of you join the working group and continue the contributions, so that hopefully the final output will be a standard that will be useful for as many people as possible.
Thank you, Mariana.
Absolutely.
Thank you. Thank you, Daniel.
Thank you, everyone, for participating. We just wanted to say a few words. I guess this has really been the first session that we have. There is maybe 11 more, I believe, that are discussions. So 9 more, my bad. We would like your feedback. We would like to understand if you thought that this was the right format, if the discussion developed the way that you expected or that you would have liked to see. So we're going to share the feedback link on the same document of workshop 3 bar links, so you can see it there as well. Now, do you have anything else to add?
No, thank you everyone for joining. Well done for a good discussion. And yeah, that was just the kickoff. We have many more sessions to go and interesting stuff. And as we go, we're going to also see, like Kostas said, how different proposals are being integrated together. So there's a lot what to expect.